So, ladies and gentlemen, I want to welcome all of you here. We have already looked at the simple regression model. Okay, we have already looked at the simple regression model. Let me just remind you a little bit. We ran this model in R. I mean, if you have you have already written it in R. So if you have it in R, you can follow me there. Okay. When you run this and you get this down here, we did this where the quantity demanded of a product is affected by the price of the product P. The quantity is Q, is affected by price P, is affected by the complement price C, is affected by the average income of the people, which is M, is affected by the location of the shop. The location of the shop. You remember that we did all this, right? You remember?
Yes, please.
It's affected by the occupation of the people and religion of the people. Okay. When you run a simple regression, and we did that simple regression the last time, it was something like this. We did a simple regression like this. We actually even plotted it like that. We plotted it. Where is a plot? That's a plot. So we plotted it, and they were able to show all the things. We did this one the last time. Now we're going to do multiple regression. I believe that we even ran the multiple regression, and this is the multiple regression. Okay. So in this multiple regression, look at it here. In this multiple regression, you have all the variables and how they are affecting. Now you will get a similar thing like this, a similar thing like multiple regression like this in the exam is compulsory. You'll get a similar thing like that. And you'll be answering 13 questions on this. 13 questions. So what I'm going to do right now is I'm also going to ask you 13 questions on this very one. And then based on the answer and the knowledge you are getting, you should be able to use that knowledge to also answer the one in the exam. Is that fine by all of you? Is that fine by everybody?
Yes, Doc.
Okay.
Yes, Doc.
So when you run a multiple regression, this is what you get. And the first question, you're going to write it down. Please be used to writing the questions down. It will help you big time. Okay. Some of the questions are in your slide, so I'll take you to the slide and then you see them. Some of them, they are not in the slide. Okay, so when I go out, I tell you to write it, please write it because you're not in the slides. So this is the first question. Write it down, please. Specify the entire regression model based on your regression results using the same labels as R. So this is not Python, this is R. Write it down because you will get a similar one like this. And this is actually 6 months. So I want you to be able to understand. Please, do you hear some sound here? Do you hear some sound?
No, please.
All right, okay. So kindly specify the entire regression model, write it down. Now, what does this mean? What does this mean to say that specify the entire regression model? Anybody who has an idea can raise a hand. But I'm talking still though. When you say specify the entire regression model, the question wants you to write the model using the beta parameters and the names that were used. Using the beta parameters and the names that were used. So your eye must be looking at the regression table, the result, this one, in the answer question paper. Your eye must be looking at this. And then you specify the regression model. The first thing to write is the response variable. Now, in this very example, which variable was a response variable? And it is still the response variable. Who can remind us? Which variable? Darren?
Doc, the Q.
The Q, exactly. So the first variable you're going to write down is this Q. That's what you're going to write first. So you write Q like this. Then you write equal to, then you write beta naught. Beta naught represents the intercept, which is this one. Okay. Then that intercept doesn't have any independent variable. Then you write plus, and you write beta 1. Beta 1 is the first independent variable. What is the first independent variable? Looking at the regression result, who can tell us? What is the first independent variable? Yes, constant. Constant.
Price.
Price. So you write the price. You don't write the full name for price because in the result, it has been written as P. So you just use P. After that, you write beta 2, and then you include the next independent variable. Which variable is that? Who can see it? Jillian.
C.
C. Then you write beta 3. Which variable is the next one to document? Doreen.
M.
M. That is for average income. Then you write beta 4. I hope you are doing it, by the way, all of you. Which variable will you write? Nanaya. Nanaya.
Lock.
Sorry?
LOC.
It's not only LOC.
Mm.
It's not that. Juliet.
Lock urban.
That's the correct one. Okay. Yeah, you get a point. It's everything you're writing on.
Yes, I get it. Okay, thank you.
Lock urban. That's what you write. Then plus, you write beta 5. That's why I'm actually doing it with you. What will be the next variable to write after beta 5? Yeah.
So, teaching.
Teaching. That's correct. So you write it exactly as it is. So don't go and use your own acronym. Then you write beta 6. What is the next thing to write? Cornelia.
Trading. Trading.
Trading. Okay. You write it nicely. Be careful with spellings. This is 6 marks. Then you write beta 7. What is the next to write, Thelma?
The real Christians.
Real Christians. I just hope that you are all writing. If you are not writing, it's not good. Real Christians. Suppose it is actually Christians, but the person wrote Christian, the person gets 0. So please pay attention to exactly how it is written. Then you write beta 8. What is the next one? Vida.
Real Muslim.
Real Muslims. Then what do you add? Who can tell us? What else do you write? What else do you add? Ayram. Ayram. Isaac.
Error 10.
Good. So you do plus, then you add the error term. If you don't add the error term, everything again is error. Okay. If you don't add the error term, everything is 0. So it's very important that you understand how it is working. All right. So this is 6 months we just poured here. Okay. We are done. We've been able to specify the regression model. This is exactly the way it's supposed to be. The next question, please write it down. Question number 2. We said we are doing 13. Next one is write the estimated regression equation correct to 2 decimal places. Write the estimated regression equation correct to 2 decimal places. Now, how do you write the estimated regression equation correct to 2 decimal places? How exactly do you do that? Yes. So to write the estimated regression equation, go back here. The same thing you wrote, you're going to write the same thing, but this time you are going to replace the betas with numbers. So the beta naught, the first number for the beta naught is what? 280.27. So you write beta here equals to, instead of the beta naught, you write 280.27. Then plus beta 1. Instead of beta 1, what do you write? Instead of beta 1, what do you write? Darren?
No, we write minus 3.15.
Very good. That is why it's important to look at it before you write a plus. So you realize that this one is minus. So you come and pick the next one here. And you write minus 3.15 P. You will add the P to it. You will have to add the P to it. Okay. After that, what is the next thing you have to write? Who can tell us? Cornelia.
Minus 0.1050 C.
0.2, you say it's correct to 2 decimal place. So you don't have to say 0.105. 2 decimal place. That was a question.
So minus 0.10.
It's still wrong.
Minus 0.11.
So is that how you're going to do it in exam? You're going to be changing. Anyway, you're learning from here. So make sure that you don't repeat that mistake. Then you go to the next one. What is the next one, Deborah?
Minus 0.98 M.
Minus 0.98 M. What is the next one? Who can tell us the next one? Aram. Aram. Juliet.
Minus 5.11.
Minus 5.11 what?
11 log urban.
Log urban. Log urban. So you have to write it exactly like that. And then you keep going, you keep going, you keep going. What's the last one? Who can tell us the last one, Vida? Vida Benson.
So I'm coming.
You're coming.
Yeah,
Deborah.
the last one is plus. It will be minus 23.01 real Muslim.
Minus 23.01 real Muslims. And you don't need to add the error term. So that is how it's got to be. Okay. I just hope that you're all following. In fact, in reality, this is exactly what you're going to write. No. This is exactly.
Look, thank you. You said you don't need to write the error term. Does it mean that we will not be penalized if we pay a chance, right?
You'll be penalized. Sorry. You cannot write the error term.
Because in the first one, I said you have to write it.
Yeah. Here you do not have to write it.
Okay. We shouldn't write it.
Never.
Okay. All right.
All right. Write this down. This whole equation, write it down. You're going to use it later for prediction. Predicting alone is 18 months. So it's important that you write this down. It's important. I mean, whilst I'm doing it, I'm expecting you are doing it. If you're not doing it, you are really losing. I can promise you that. Please. If you are just watching the screen and not doing it, that is a big wahala. Okay. So that's question 2. Let's go to question 3. And the questions are all coming from these results, okay? The R results. Question 3 is which regression, okay, no. Let's go to a different one first. Question 3 is a regression model well fitted? Write it down. Is a regression model well fitted or reliable? Is a regression model well fitted or reliable? That is a question 3. And the 4 part is interpret the answer you used, the statistic used. Interpret the statistic that you used.
Say next, then not the sound that still come here. But there's lights. Not lights. I said the sound. Okay, you don't go to.
Normally the people who don't pay attention, they are the ones whose microphone comes off. And when it comes off, it's because they are not paying attention. So they don't know. So they are not paying attention, even in their secrecies. It happens. Okay, so is a regression model well fitted? You have to use something that is known as the multiple R squared to answer that. The multiple R squared. It is also called the coefficient of determination. The coefficient of determination. That's a multiple R squared. So what is a multiple R squared? Well, the multiple R squared generally tells you the variability in the dependent variable as a result of the variation or variability in the independent variables. That's it. It tells you the fraction of the total sample variation. A fraction of the total sample variation in the dependent variable that has been explained by all the independent variable. Sometimes we say that has been explained by the entire regression line. So you use the R squared to determine whether the independent variables you selected are good. And therefore the model is good or is not good. If the independent variables are not good, it will be shown in a very lower R squared. If the regression model is well fitted or reliable or dependable, then the R squared should be bigger than 50%. Note it down. The R squared should be bigger than 50%. So now let's go to our result and check. Looking at our result, if you're looking at our results carefully, is our regression model well fitted or is not fitted? Is it well fitted or is not well fitted? Yes, Juliet.
It's well fitted because our R squared value is 98.84%.
Correct to 2 decimal places.
So 98.84.
Correct to 2 decimal places.
So 98.80.
Correct to 2 decimal places. Thelma.
0.99.
That is it. So it's 99%. It's important that you understand these decimals. Okay. But the answer you gave is correct that the R square is bigger than 50%, is 99%, and therefore the regression model is reliable. Okay, now we know that. How will you interpret the 99%? If you look at the definition of the R square I gave you, how would you interpret the 99%? Anybody? Well, if you don't know, I'll interpret it for you. Write it down. Write it down. The 99% means that 99% of the variation in the quantity demanded of gene bitters. It means 99% of the variability in the quantity demanded of gene bitters has been explained by all the independent variables. By all the independent variables. No.
I'm sorry, that was an old hand.
You have made that mistake 3 times. Please, just check carefully.
Okay,
All right.
thank you.
So that is how you interpret the R square, and you must learn how to interpret every R square. Now let's proceed by looking at the next question. The next question is, which independent variable? Oh, no. Before we go there, there is another thing that you can see here. Okay, it is not the R square, it is adjusted R square. What is the use of the adjusted R square? Now let me explain before. No, when you put irrelevant variables, suppose you are trying to look at the determinants of demand and you put broken heart. It's irrelevant variable. It doesn't determine demand or not. But suppose you put that value, that variable there. The R square must penalize you for including irrelevant variables. Okay. So the question is, if a variable is irrelevant and you include it in the model, the R square must come down, but it doesn't come down. Hence the adjusted R square. The adjusted R square, here's a point, penalizes the inclusion of irrelevant variables in the regression model. Write it down. The adjusted R square penalizes the inclusion of irrelevant variables in the model. Hope you got that. So I want you to understand clearly that, okay, so let me ask you, if the R square, okay, the R square, let me write it here. If the R square is equal to the adjusted R square, what would that mean? Given the definition we have given for the adjusted. If the R square equals adjusted, Doreen.
Doc, it suggests that there's probably no presence of any relevant variable in the model.
Perfect. It means that irrelevant variables are not inside the model. All the model you incorporated are relevant. Okay. So that is another importance of the adjusted R square. Okay. Now let's go to the next question. Question number 6 or 5. I don't know. Okay. And that is, which regression coefficients are statistically significant? I'm putting it on the screen. Which regression estimates or which regression coefficients are statistically significant? Justify. Now, how do you know whether a regression coefficient is statistically significant? Here's a rule. Check the p-value of that independent variable. If the p-value is less than 0.05, it means that that independent variable is statistically significant. Write it down, you'll forget. Okay. So if the p-value of that independent variable is less than 5%, it means that that independent variable is statistically significant. So let's go. How do you determine which variables have a p-value less than 5%? Look at this column. There's a column in your data which has PR at the top. PR means probability. Probability value. That is the same as p-value. Probability value. Probability value is the same as the p-value. So you are going to check the values and be sure which one is less than 5%. Let's start with the first one. I'm talking about the intercept. We don't normally deal with the intercept, but I'm talking about the intercept first. The p-value for the intercept, check it carefully, is 2.00 E minus 0.08. What does that mean? It means that, listen, pay attention. it means there are 8 zeros. This 8 means there are 8 zeros before the 2, the 2.00. There are 8 zeros before the 2.00. And after the first zero, you bring a 1. So here, what I've done is I've written 4 zeros here. If I add another 4 zeros here, I get my 8 zeros, like this. Then after the first zero, you bring a dot. So these are the 8 zeros. Then before these 2, so that is 2. And then you add the 0, 0 as well. Okay. But when you look at this, it simply means that the answer is approximately one number. When you are looking at this, it means it's approximately one number. Anybody can give us a clue for that? Approximately, this is equal to what? No.
0.
0. Okay. So technically, we're not interested in the intercept. But if we were, we would have said that the intercept, is it significant or insignificant? Is it significant or insignificant? Constant. Isaac.
Significant. Yes.
Significant. Very good. So let's go to price. Okay. And by the way, anytime you talk about whether it's significant or not, okay, always try and round it up to 2 decimal places. I just want to use 2 decimal places here. Of course, you can do more, but for this, I just want to use 2 decimal places. So let's talk about price. Is it significant or is not significant? Correct to 2 decimal place. It's tricky. Who knows the answer but is slightly confused? Yes, Bruce.
It's not significant.
It's not what?
Significant.
Explain.
Because the value is 0.05 and the concept says that it should be less than 0.5. For that matter, it's not
Actually,
significant.
nobody asked me, but then it should be 0 less than or equal to 0.05. This is it. This is what it should be. So it's not less than, but it's less than or equal to. So change it. Constant.
What it means is that it is significant.
Sorry? Why?
Because if the rule says that it should be significant if P is less than, the probability is less than or equal to 0.05, then the value we are having here is 0. For P, it is 0.05 to 2 decimal places. And it is equal to the rule given in the P that it should be less or equal to 0.05. So it should be significant.
Very good. So price is significant if you are to take 2 decimal places. If you were not taking 2 decimal places, it wouldn't be significant. Take note. Let's go to complement price. Is it significant or insignificant? Complement price. Is it significant or insignificant? Ishmael.
No, it's significant.
Very good. Why?
Because as the rules denote, the p-value should be less than or equal to 0.
No, tell me what it is first. So because
the p-value we have is 0.001 at 2 decimal places, which is equal to the p-value in the
I love that. I love the way you've answered it now. Excellent. Let's go to income. The average income of the people, is that significant or insignificant? And why? Income. Is it significant or insignificant? Nanayo.
It's not significant.
Why?
That's because a p-value of 0.20 is more than the alpha of 0.05.
Very good. Guys, if you don't know what we are doing, be writing what they are saying. It's very important. Okay. Log urban. Is that significant or insignificant? Anybody? Log urban. Juliet.
So for log urban, the P value is 0.19, which is greater than 5%, so it is not significant.
Excellent. Org teaching. Significant or insignificant? Org teaching. Org teaching. If we're
The p-value of 0.0 makes it insignificant because it's less than 0.05.
perfect. Org trading. Org trading. Org trading. Doreen.
Org trading is significant because the p-value of 0.0080 is less than 0.5.
Good.
0.05.
Real Christians. Real Christians. Significant or insignificant? Real Christians. Darren.
Real Christian is also significant because the p-value of 0.00016 is less than 0.05.
Good. Real Muslims. Real Muslim. Ishmael. Ishmael.
Hello, Doc. Yes, it's significant because it's still 0.00, which falls within the less than or equal to 0.05.
Very good. So all of these are known as partial significance. Write it down. Partial. Because you are looking at them one by one. They are all called partial or individual significance. Partial or individual significance. Now, that means individually, when you pick them one by one, some are significant, some are insignificant. What about when you combine them? What about when you combine them? That takes us to the next question. Okay, so the next question is going to combine them. So let's look at how that actually works when you combine them. So in the combination, here is a question. The question is, determine the joint significance of the regression and explain it. In other words, are the coefficients jointly significant? Write it down. You forget. Are the coefficients jointly significant? Have you written it? Okay. So that was question 7 or 8. Okay. Are the coefficients jointly? Again, you will go to your table and you will have to use the p-value of the F statistic. It's normally at the bottom. You will use the p-value of the F statistic. So write it down somewhere that use the p-value of the F statistic to determine joint significance. Use the p-value of the F statistic to determine joint significance. Okay. So when you look at the p-value of the F statistic, the p-value of the F statistic is approximately what number? You can tell us. The p-value of the F statistic is approximately what number? There, Rebecca.
0.
0. Okay, therefore, what will be the conclusion? Are the independent variables jointly or collectively significant? That's another word. Are the independent variables jointly or collectively significant? You can tell us. The rule is that when the p-value is less than 5%, it's significant. Yes, constant.
Jointly, they are significant because their joint probabilities is 0, less than 0.05.
Very good. So since the p-value of 0 is less than 5%, we can say that the independent variables are jointly significant. Very good. Now, pay attention. Because the next set of questions, by the way, all of these are 5 hours. Okay. The next set of questions is going to be more about interpretation. Interpretation. So let me show you one of them. It can be any of the variables. Write it down. Interpret the coefficient of the price of gin. Interpret the coefficient of the price of gin. When you get similar ones in exam, you are not bothered because you've learned it. Interpret the coefficient of the price of gin. How do you interpret it? You always must start with on average. So let me show you how you got to look at it. In fact, it's best if you say it and write it. It's best if you say it and if you write it. So who can read this from us? We are looking at the coefficient of price, and the coefficient of price is negative 3.15. How do you interpret it? Who can read it for us? Deborah.
On average, P negative 3.15. That's on average, given the complement price of gin, average income of the people around a shop, location of the shop, occupation and religion of the people. A 1 unit rise in the price of gin bitters will reduce the Q of Brukutu gin bitters by 3.15 units. Albeit this insignificant at the 5% alpha, it is significant at the 10% alpha level.
Very good. Guys, let's pick on some keywords. If you say all of this without bringing the word on average, you are wrong. Take note. If you say all this and you don't bring the word on, if you don't say that, if you say holding all other factors constant, you are wrong. If you say holding all other factors constant, you are wrong. You have to mention the factors. It's very important you are following this. So you can see that. And also price. When you look at price, is it dynamic or static variable? Is it dynamic or is a dummy variable? What do you think? Price, is it a changing variable or Simon?
It is a changing variable.
It is a changing variable. And therefore, that is why we use words like rise. Rise. Otherwise, you will not use words like 1 unit to rise or 1 unit to increase in the price of gin. When you did a 1 unit increase, you said will reduce the quantity demanded. Why reduce? Why the word reduce? Why not also saying it will increase? Doreen.
Doc, because of the negative attached to the price, that's negative 3.15 because of the negative sign.
That's it. Now, watch it. I did not also say will lead to a $1 or 1% or anything. Instead of the unit of measurement, gallon of something, dollar of something, we just use what? Unit. Unit. So remember, it's just units. Okay. It is significant. I mean, technically, when you look at price, correct to 2 decimal place is significant at 5%. But when you don't do correct to 2 decimal place, it will not be significant. That's why he said it's insignificant at 5%. But it's actually significant at 10% because the p-value is less than 10 when you check it. The p-value is less than 10. So, will you be able to interpret any variable that is dynamic like price? For example, complement price, income. Income. Would you have been able to interpret a coefficient of income? Income. If you were to interpret it, I'm sure you can do it. Watch carefully that because I was interpreting the coefficient of price, when I was saying that giving blah, 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 I did not say giving price. Okay, let's go back to the thing. Because I was interpreting this one, the coefficient of price, I did not say giving blah, blah, blah. I did not include price. And the same way, if I'm interpreting the coefficient of the complement price, when you are mentioning giving, you will not include the complement price. When you are interpreting that of income, you will not mention the income. So, for example, if I was interpreting M, I would say that on average, giving price, so you mentioned price of Jane, complement price of Jane, then you jump income, the location of the shop, occupation, and religion of the people. That's how you put it. And you don't have to say occupation, teaching, occupation, trading. No, they are all occupations. Say occupation and religion. Okay. Interpretation alone is 9 marks. So that's why I'm delaying here. Okay. Any question on interpretation? Right. Now, that was a dynamic variable. What if the variable is a dummy? Location urban is dummy. Occupation teaching is dummy. Occupation trading is dummy. Religion Christian is dummy. Religion Muslim is dummy. What if you were interpreting the coefficient of Muslim? Now, Muslim is not increasing, Muslim is not reducing. So the way you interpret Muslim is going to be different here. So you always start with, of course, on average. Giving, then you mention all of them again. The only one you will not mention here is what? If you are saying that giving or holding, blah, 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 which one wouldn't you hold constant? Which one wouldn't you hold constant? If you were interpreting religion Muslim, which one will you not hold constant? Anybody? Constant.
Religion Muslim.
No, not religion Muslim, but what? Not specifically religion Muslim, but what? Darren?
Real Christians.
No, no real Christians, but what? There's one you will not hold constant. You say it as well. You say holding or giving price, complement price, blah, blah, blah. But which one will you not hold? Oh, it's just religion. You don't have to say religion Muslim. Neither do you have to say religion Christian. It's religion. So giving location, occupation, and that's it. You don't have to say giving religion Christian. No. Because Christian is still part of religion. It's religion you're interpreting. So you will not talk about anything related to religion. Okay. All right. Then you say that after you've said all this, let me take you back here. You will say that quantity demanded, that's how you started all. Quantity demanded, this is quantity demanded of gin is predicted or expected to be, guys, this has to come. It's predicted or expected to be 23.01 units less. Remember the coefficient of religion was 23.01. So you say 23.01 unit less, and you have to have the reference category for religion in your mind. If you check the result, all of the religions were mentioned, but there's one that wasn't mentioned. And last week we said that that one is the reference category. So religion, which is the reference category? Doreen.
That's the Buddhist.
Very good. Excellent. Now, when you go to occupation, which is a reference category? Occupation. What is a reference category there? If we're
Fishing.
fishing. And location, what is a reference category? Location. Juliet.
Rural.
Rural. So know the reference category so that when you're interpreting the one that is showing, you say it in relative to the reference category. So you say that after you've heard everything on average, given blah, 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 blah. Then you say that quantity demanded is predicted to be 23.01 units less if the people are Muslims than Buddhists. And this is actually significant at 5%. It's also significant at 1%. It's also significant at 0.1% because the value was 0 anyway. Constant.
Why do we say average income and not just income? Why are we talking about
because
the
it
average?
comes from the storyline, the preamble. When the preamble was being given from last week, from the beginning, it mentioned that M stands for the average income of the people. It's from the story. It's from the preamble. And the one you always get in an exam will also have a preamble that will be given to you. So you look at the story preamble to be able to use the same words. It's not because it's an average or anything. No, we've not done anything. That's a word you give to us. Okay. Any other question? Okay. So now you have mastered interpretation. Interpretation is very key, guys. Interpretation is very, very key. So now that we've had interpretation, very key, we are left with one last one. And it is a very important one. So pay attention. I think I did also mention that after some few minutes, I will excuse you for about 5 minutes or so, and then I'll return. Very soon I'll be doing that, and I'll let you know. Okay. Any questions so far? There are 2 reasons why we do regression. Who can tell me? Yes, Nanaya.
Doc, sorry, just concerning the interpretation we give on the Muslim. I didn't get it. And the interpretation we gave for the last thing we spoke about.
Muslim.
Yes. He said the reference category is usually not mentioned.
In the table. It's not mentioned in the table.
Okay. But in our interpretation, that is
you
what
have to bring it. You have to know it.
But
yeah.
I realized that the Christians didn't appear in our interpretation.
Because we are not interpreting Christian, we are interpreting Muslim.
Okay. So basically, you compare Muslims to the reference category. So if it was religion, Christian, it should have been Christians and then Buddhists.
Okay, my time is up. I'm just going to do that 5 minutes, then I'll come back. Okay.
Okay.
All right. So please check your screen and learn from it. So this is 18 marks, and the question is a very simple question. I told you regression is for 2 things. The first thing regression is designed for is inference. Inference, write it down. Regression is designed for inference. You use it to establish causality. You use regression to establish causal relationship. The next thing regression is used for is prediction. So once you have built a model and validated a model, you can use a model to predict the quantity demanded of gene test. So I'm going to look at the easiest prediction. And then when you want to do the prediction, let me show you something. Let me show you something here. When you want to do the prediction, what you do is that you use the estimate. The estimate. That is what you use. You use this estimate to do the prediction. Okay. And so you ask yourself that what is the estimate for each of the independent variable? That is what you are going to be using. The estimate for each of the independent variables. The first estimate for the price is negative 3.1. So you use the estimate. Okay, let me take you back here and let's see whether we can predict quantity demanded. The question is this, it's simple. How much higher is the quantity demanded of gym bidders predicted to be if the price rises by 8 cedis? If the price should rise by 8 cedis, what would be, how much higher is the Q going to be? So this one is looking at what is known as change in the Q as a result of the change in the price. Now, what do you need? We all know that the partial derivative of the Q with respect to the price is the coefficient or the estimate. What is the estimate? The coefficient of price. You can remind us. Darren.
No, it's negative 3.15.
Negative 3.15. And now we know this one. We are told that the price has increased. So this one, we know the value. The value is what? 8. Okay, no, so they are asking you to find the change in Q. That's what they are asking you. What do you do? What do you do? And what will be the answer? What do you do and what will be the answer? Yao.
You cross multiply. So change in Q is equal to negative 3.15 times 8.
Good. The answer is going to be negative, right?
Yes.
So it's going to be 25 or something, 23 or 25 or something. Okay. Now, if I should make this one 3.16, that is going to be different. But anyway, the value is going to be something like that. I made it 3.16, but no problem. You can make it 3.15 or 3.16. And you're going to get something approximately 24 or 25. Okay. So what that means is that if the price should increase, we know quantity is going to fall, but quantity is going to fall by approximately 25 cedis, 25 bottles, because that is bottles of gin, bottles of gin. So you see, this prediction is only for price, and that's it. But what about if we change all the others? What if all the others should change? Now, that is the biggest prediction question. Now, that is 18 marks in the exams. So please pay attention so that you can follow through. So the first question is compare the predicted quantity demanded of gym bitters. Compare it. So you're going to have 2 different quantity demanded of the gym bitters. One of them is quantity demanded. Let me just delete this, then I talk, because this is deep to my heart, because the questions here are deep. So we are looking for the quantity demanded of gym bitters, but then there are 2 scenarios. The first one is made by Muslim traders in an urban area. That's the first one. Take note. So this quantity demanded is made by what? Muslim traders in an urban area. Let's compare that with that of another quantity demanded of gym bitters, which is rather made by Buddhist fishers in a rural area. Buddhist fishers in a rural area. Question. And then it says that given that in both situations, okay, the gym bitter cost 15. Okay, so he's telling you that the prices are not different from the 2 scenarios. Also, the complement price is 15. That is also the same in both. And then the income, the average real income of the customers is also 20. So now, tell us what would be the quantity demanded. And in both scenarios, tell us which one will have more quantity demanded. Is it a first scenario, who are Muslim traders in an urban town, or is a second scenario, who are Buddhist fishers in a rural area? That's the question. Guys, to do this, you must have your estimated regression equation ready. This one. This is the estimated regression equation. So we're going to substitute each element inside for each scenario. So let's look at the first scenario. So the first scenario, first you write your estimated equation. The first scenario, the price is what? So you're looking for this value. The price is what? We are told the price is what? Who can tell us? Well, it's the same for the first scenario and the second scenario. But the price is what? Now,
15.
15. So you put 15 here. Now, the complement price is what? Who can tell us? The complement price. Raise your hand and tell me the complement price. Nanaya.
I think it was also 15.
Also 15. And then the income. Income is what? Darren?
It's 20.
It's 20. So you have 15, 15, 20. Now, so because those were the same for both scenarios, so that's not a hala. Now let's get to the real deal. We are told that in the first scenario, they are Muslim traders in an urban town. Now watch this. So when you come to location urban, these people are Muslim traders in an urban town. Now remember that this is a dummy, and dummy is always 0 or 1. So this log urban, in the first scenario, log urban will be given a value of what? Is it 0 or 1? Looking at that first part, we are told that these are Muslim traders in an urban town. So log urban, in this first scenario, will be given a value of what, Vida?
It says 1.
It's 1. Because they are not in a rural area, they are in an urban. Now, in that first scenario too, org teaching will be given a value of what? Who can tell us? Org teaching. Remember, they are Muslim traders in an urban town. Org teaching will be given a value of what? Juliet?
0.
0. Why?
Because what we are looking at is traders.
Very good.
Occupation traders, yeah.
So still on you. Org trading will be given a value of what?
1.
1. Very good. Now, real Christians will be given a value of what? Anybody? Real Christians. If you still remember the first scenario, who they were. Darren?
That should be 0.
Why?
0.
Why? Why 0?
Because we are looking at Muslims.
Very good. So Christians should be given a value of 0. Okay. And then the last one, real Muslim will be given a value of what? Vida?
It's 1.
Is 1. So you see, everything that we are discussing here is right here. Everything that we are discussing is right here. So when it come here, the substitution has been made. Okay. The substitution, you see that is 1 here, 0 here, 1 here, 0 here, 1 here. So you now take your calculator and add all of these, and that will give you a value of 137.0903 quantity demanded. So the first scenario, the predicted quantity demanded under this scenario is going to be 137 bottles of gin bitters. Very good. Now we go to the same situation and then do for the second scenario. Now remember, the second scenario, the people are what? They are Buddhist fishers in a rural area. Don't forget that. If you will forget, write it down. Buddhist fishers in a rural area. Okay, so let's go to the scenario. So P will be given a value of what? Let's start again. Darren?
15.
C will be given a value of what? Ishmael?
15, dog.
M will be given a value of what? Constant. 20. Log urban will be given a value of what? Remember, the people are Buddhist fishers in a rural area. Log urban will be given a value of what? Juliet?
0.
Org teaching will be given a value of what? Elon?
0.
Org trading will be given a value of what? If we're
0.
real Christians will be given a value of what? Cornelia?
0.
Real Muslims will be given a value of what? Juliet.
0.
Guys, you see the way I'm walking you step by step? What you are
Where is the
analyzing.
Buddhist?
Sorry? When you are analyzing this in an exam, you have to go step by step. Okay. And then you substitute all. So when you substitute all, the last 4, they're going to be 0, 0, 0, 0, 0, even up to the last 5. Okay. And the only thing that is left is just the price, complement price, and income. Yes, if what?
I was expecting to see the Buddhist. Am I lost?
No, Buddhist is not here because we said Buddhist is a reference category.
Okay.
Okay. This one, we have already written it, and we wrote it by looking at here, the regression. And you can see that here, Buddhist was never given because Buddhist was a reference category among the religions. The same way among the occupation. You see, we have teaching and we have trading, but fishing was not given, right? So the one that is a reference category is not added in the regression result. But then it doesn't mean that because you have not added it, you cannot ask a question about it. So that is why you see that in this one, we've asked a question about Buddhist fishes, even though Buddhist and fishes are not in the thing. Okay. But you should know the scenario. Why? Because a story will be given to you from the beginning, and you'll be told that there are 3 religions. We have Buddhism, Christianity, and Muslim. So you'll be told that. So when you get to the real nitty-gritties of the answering, you should know from the top of the preamble that Buddhist is a reference category. Do you get it, Ifwa?
Yes, it's clear now. Thank you.
Okay, so when you add this, you're going to get 211. So now let's compare the 211 and then the 137. Okay, so the first one is 137. Which one is more? Which one is giving us more quantity demanded? The first scenario or the second? First or second, Darren?
Doc, the scenario 2.
Good. So what is driving the difference then? What is causing the difference? There were some things that were the same. So what is causing the differences? 3 major things are causing the difference in the result. What is driving the difference in the result? You know, they all had the same price. They all had the same complement price. So what is driving the difference, Juliet?
It's the location, the occupation, and religion.
Perfect. That is it. So these are the things that are causing, because those were the ones where the changes were. Okay. So those were the ones where the changes were, and that is why it is important to recognize that. Occupation, and then religion, and then location. That is it, Simon.
Doc, thank you very much. Please, the what do you call the price and others were different. Were the same, but the income was different. So can that also?
Income was not different, though. Both of them had an income of 20. Check it.
Oh, okay.
Yeah.
I didn't see that. Thank you.
All right.
Okay. So if it had been different, it would have also influenced
Exactly.
it, right?
If one was 20 and the other was 40, you would have included income.
Oh, okay. I'm grateful to you, sir.
Right. Now, there is another thing known as multicollinearity. We looked at it the last time, and I want to just mention 2 points. I don't want to go into too much details on multicollinearity. But now, if you can remember the last time, we said multicollinearity exists when 2 independent variables are highly correlated. I think we did that. We looked at a lot of things. Now, first point I want you to take note is that dummy variables, there is no need to check the collinearity or the multicollinearity of dummy variables. Write it down. There is no need to check the collinearity or multicollinearity of dummy variables. And I want you to go and find out why. Go and find out why. Now, I'm going back. So it means that if there is no need to check multicollinearity of dummy variables, then it means that when you decide to do collinearity, and what I mean is this, I'm coming to show you. Suppose you decide to run for the correlation, a collinearity. And I'm going to do that here very soon. Okay. If you decide to analyze the collinearity of the dummy variables, of all the variables, including the dummy variables. Where is this? Collinearity. Oh, no. Okay, let me just search for it quickly. Okay. So I'm going to show a certain thing. I mean, what you are going to see is just a result, okay? Suppose I try to generate collinearity. Look down here, okay? And this collinearity, it has a location here. Now, collinearity or multicollinearity is a problem. It's a problem, okay? One way you detect it is using something called variance inflation factor. Just note it down. Detect it using variance inflation factor. If the variance inflation factor is more than 5, it's severe. Okay, if it is more than 5, it's not good. It means that that variable is a problem. It's suffering from severe multicollinearity. If it is more than 10, that variable is suffering from dangerous multicollinearity. Okay. Now, I just ran the VIF for my variables. I just ran them, and you are seeing the results here. It is giving me results for location, occupation, and religion. And I'm saying that this is where you don't check. You ignore the variance inflation factor for these dummy variables. And I've told you to go and find out why. So we are going to focus on just the variance inflation factor for the first 3 numerical variables. The numerical variables are price, complement price, and then income. The one with the biggest variance inflation factor is the problematic one, is the most problematic one. The one with the biggest GVIF is the one with the most problem. So looking at our data here, which variable do you see as the most problematic variable, independent variable? Constant.
The P, the price. P.
The price, exactly. So you may get some situations like that where you are being asked to identify the 2 most problematic variable or the 3 most problematic variable. Just identify that those ones are the ones that have a higher VIF compared to the others. Now, in this very case, all of them are problematic, to be honest, because all of them are above 10, but the most problematic is price. Which one is the least problematic? Which one is the least problematic? If you check carefully. This one you must have an eye. Tell me.
The 10.38.
Which variable is the least problematic?
Say the C.
The C, that's it. Ladies and gentlemen, that brings us to the end of the entire caboodle. That is the end of the entire caboodle. So now you have been given the tons of information that will help you to be able to prepare for your exam.